you for giving me the call, Yogesh. As I mentioned to Samarth and a few others this morning, I had a mandatory 8 to 9 for my job. Ford Motor Company, the VP had set up a call for all of manufacturing department. So apologize for the delay, but I'm glad to be here and really thank you all for this opportunity. Okay, all right. I see a few smiling faces. So let's go ahead.
Okay. Kaustav, tell us when to start. Kaustav, should I start? Okay, great. A warm welcome to everyone. We at ASME VJTI have brought for you yet another engaging and intellectually stimulating session where we have the privilege to interact with exceptionally accomplished guests from around the world. If you've followed our previous webinars, I'm sure you know what ASME is. In case you've missed them, do not fret. You will be able to access them soon on our YouTube channel. So subscribe to our channel and follow us on social media to stay updated with all our events. For our newcomers, ASME, or the American Society of Mechanical Engineers, was founded in 1880. It is a non-profit professional organization that enables collaboration, knowledge sharing, and skill development across all engineering disciplines, while promoting the vital role of the engineer in society. In other words, it's where engineers across all domains can come together to acquire new skills, discuss ideas, implement them, and further science and technology. A special mention here of Professor Palle, the faculty in charge of ASME VJTI, who has been the guiding light for our students. To begin with today's event, I would first like to introduce myself. I'm Adya Navalkar, and it's my pleasure to be your host. I welcome our today's esteemed guest, Mr. Prashant Jawakar. Sir, we are incredibly honored to have you here. Mr. Prashant Jawakar is a 1991 VJTI alumnus of mechanical engineering. After his bachelor's, he gained working experience of over a year and went on to pursue master's in mechanical engineering from Oklahoma State University in the US. He later did MBA in international business from the University of Michigan, Dearborn. Currently, he's working as a regional manufacturing business manager at the Ford Motor Company, where he's worked for 22 years across multiple divisions, ensuring that the company could really go further. He provides a mix of technical and managerial skills, which accounts for his 25 plus years of industry experience across multiple domains. Furthermore, he's a Kaizen Sensei and also a Six Sigma Master Black Belt Level 2. He's experienced in public speaking and panel representation at events and is an experienced teacher, trainer, and mentor who's trained several engineers. He's a man of impressive feats, and today he'll be shedding light on lean manufacturing for us. Now, to tell us more about our esteemed guests, I call upon a familiar face, Mr. Yogesh Tambat, who had given a webinar with ASME VJTI on product life cycle just a month ago. Tambat sir has worked as a design engineer at Onward Technologies and was the lead mechanical engineer in Continental Automotive Systems. Currently, he's working as a RF antenna mechanical D&R at Ford Motor Company and is thus a colleague of Mr. Jawakar. Please welcome Mr. Yogesh Tambat.
Hello, everybody. Nice introduction, Aditya. Adya. What am I supposed to tell about him now? You have explained everything. What I can tell about Prashant is he's not just he has amazing credentials on the work side. He has offline credentials too. Like he's a hiker. He has visited Everest Base Camp. He is a biker. He has a bike. He bikes miles and miles. Yeah. And he's in Maharashtra Mandal of Detroit. He's a great volunteer worker. Because of him, I got introduced to Prashant like 10 years back when he was in Maharashtra Mandar. So we as a group of here try to meet on the festivals, and that's how I introduced to Prashant like 10, 15 years back. And he is also an actor. He did Ranangan, you know. He was a lead actor in Ranangan, and I was like a small one. So he is versatile, man. I don't know what else he does. Oh, he did just last week. He did a marathon, half marathon. Yeah. So he is the guy today. You know, I'm dressed casual today because I'm not the guy. Prashant is the guy, and I'm sure he's going to really educate us and create our interest into manufacturing. I know lean manufacturing, as everybody know, as I know, surface like it is optimum. What is optimum manufacturing without wasting? That's all I know. But one thing I want to share quick before I want to share one thing with you guys before I hand it over to Prashant. So here is what we started last month. So my thing was making. What is making? A mechanical, inspiring new generation. So that is from our end, my end. So last Prashant, it's good for you to know. Last month that has everything. It's a huge. Try to squeeze it down to what actual things go into product life cycle. And I'm trying to make a slide also, because that time I did not present anything because I wanted everyone to imagine it. What is a product life cycle? And that was my goal, to imagine, not PowerPoint. PowerPoint, they just read things. No, I wanted them to imagine it. So the sub part of it is manufacturing now. And we will fill up this. My goal is to fill up this product life cycle as much. It's going to be a very hard task, but and fortunately I got a great experienced guy today, Prashant Jawakar, and I really am excited myself to know in depth about product life cycle. So I'm going to stop presenting now. Was I sharing it?
Actually, no. I could not see it.
Okay. Okay. Now, sorry about that. Okay, can you see my screen now?
Yes, I can.
Sir.
Yes, awesome. Okay, my bad. All right. Can you see one? I just made one slide. Can you see this slide?
Yes, sir. It's visible.
Okay, so this is what I was talking about, making. So mechanical, inspiring new generation. So that is what I think we are starting here. We have started last month. So product lifecycle, as I mentioned, that was the main thing that we went through. And then that has a lot of other subgroups, like ocean, you know. And manufacturing is one of them, which Prashant graciously agreed to talk about when I approached him. And we will fill in those blanks as and on we go. I'm not going to take much time. I'm very sorry for that.
Prashant, just 1 second. That I would like to add one statement that today only that Government of India initiated, that is the AICT, All India Technical Education Council. They have invited Mr. Prashant as a chief guest. That the chairman of the AICT, Professor Sahasrabuddhe, he has invited him as a chief guest for the one of the Atal program, where the 10,000 faculties will be trained. So this is the new information, this new happening that just I thought that I will share with you. This is a great honor to Prashant as well as this VJTI, the VJTI alumni. Thanks, Prashant. Keep it up. All the best.
Thank you so much, Dr. Falle. I am really honored and privileged to be even considered. So I'll be very happy to address all the young teachers as well as experienced teachers. So I'm looking forward to it. Coming back to this session, I would like to really thank everybody on the call for joining, and to some key people who have been instrumental in making this happen. First is Yogesh Tambat, who's my friend, as you mentioned, not only colleague at Ford, but also a friend through the Marathi Mandar, in the Detroit area. And I appreciated him reaching out to me, and I immediately jumped on it, saying, hey, if there's an opportunity, I would love to share something, because I wanted to do something for my VJTI. And also wanted to thank Adya for the beautiful introduction, and to Samartha Vasardkar for being the liaison between you guys and me for the past few days. Saili also joined the call this past week. So thank you all for making this easy and for really leading these kind of sessions, which are incredibly useful and important for the students. Because honestly, when I was in VJTI to this day, I see that a lot of things have changed and for the better. And I really want every product of VJTI to be successful anywhere globally, right? Anywhere he or she is, they should be top class products of VJTI. So anything that Yogesh can do, I can do in a small way to help you guys, give you some overview on certain things. We may not be able to go very deep into the material, but we are open for questions. Again, I wanted to just say that if anybody has any questions, if there's a chat session, or if someone can send a question to a certain email, and if somebody can compile all those questions, I will be happy to answer them. We can also address questions during the session, okay? So before I share my screen and get going, are there any questions? Okay, great, wonderful.
None right now, but we'll keep in question answer session at the end of the session. So
okay,
we can address all the questions then.
Sounds good. Okay, so I wanted to just say that I am, Yogesh is dressed cool, I should say. I was also sitting at home, but we are all working from home here, so I don't get to wear my office clothes. So I thought this was a good opportunity to pull out the shirt and the blazer and be presentable to you guys. So anyway, but I'm super excited. Let me share my screen. Let me know when you see it. You should be able to see it now.
Yes, it's visible.
Okay, great. So this is the bio that I shared with you, and I am not going to repeat any of this because they already covered that to some extent. Yogesh did too. So what I wanted to share is, before I get into the technical stuff, who am I, right? So I wanted to basically just share take a few minutes to talk about that. Okay, so again, I'm currently in the role of the Regional Manufacturing Business Manager at Ford Motor Company. I can talk about the role in detail later if anybody has any questions. Roughly been working for 27 years. Can't believe, time flies when you're having fun. And 22 years of that has been at Ford. I did my mechanical, as you guys mentioned, I passed out in 91. Then when I came to the US, I did my master's at Oklahoma State University. And then the first city I came to look for a job was Detroit, Michigan. And I've been here since 95. Then once I started working at Ford, I also completed my MBA. I was married, and with my first daughter, only 1 year old, I went through the 4-year part-time MBA course, which was immensely helpful. I have a small family, 1 wife and 2 kids, and I know some of you guys are smiling there, but that's what I was intending to do. So a very supportive wife, Saroj. She is actually in India right now. She just flew back to see her mom, so she's in Borivali right now. And then I have 2 kids. Older one is Richa. She's 21 years old, and my son Mihir is 19 years old. They both are at Michigan State University, which is about an hour and 15 minutes away from here. And she is pursuing a pre-med career, medical. And my son is also opted for mechanical engineering. Trust me, I had no hand in that. He was involved in a STEM group at his high school, but he was doing electrical all along. But somehow he decided to go pursue mechanical. So I'm very proud of him, both my kids. And the fifth person you would ask is who's that? So that is our dear canine baby, our dog. His name is JJ, and he's a golden retriever. Again, as some of the things that I kind of do, I've been very socially active here by passion, to stay connected with my core, with my roots. I think it's very important for us to give back to the community, and Yogesh does that a lot as well. So we are very like-minded people in terms of supporting the community, and also being very sincere about your profession, but also really having fun as well, right? So all the fun activities are coming next. So I wanted to just share this. This is a I think you guys would be excited to see that. This is the old ID card from back then. You know, it was it's a great picture that I've kept. And on the left is the sweatshirt that it's the first sweatshirt of my life, because I had never worn a sweatshirt. It was always a t-shirt, but it was the thicker kind. And we were the first batch, right? In the first year, we were the 100th VJTIs, right? So because we started in 1987, so we are the 100th batch, and that's why we called ourselves 100th VJTIs. And we had the whole batch had made those sweatshirts, and it's a great moment of pride. I also wanted to at this time recognize, at least mention, and thank some of the professors who had been instrumental in my 4 years at VJTI. And as you might recognize some of these names, Professor Bhatt was the HOD, and Professor Mantha was my advisor, as well as Professor Bagul and Mr. Nakre were very close, and really put a you have a lot of blessings from a lot of these people. So again, that's my VJTI, and this is again my family. On the top left is my wife and 2 kids, and as you can see, JJ, my dog's name is JJ, and that stands for Jordan Jawkar. Jordan comes from Michael Jordan, the basketball phenom legend, and my kids picked the name, and he was Jordan Jawkar because we had to write the name on paper. So what we call him JJ. He doesn't understand Jordan, he only understands JJ, and he's 5.5 years now. As you might know, Yogesh also has a German Shepherd dog, Max, and he lovingly calls him Makia. And for us, Jordan, but I sometimes funny call him, his Marathi name is Janardhan, so he's Janardhan Jawkar. But anyway, that's JJ. This is one of my passions, the motorcycling, and I've also had ATVs before. So I've been riding for almost 20 years now, gone through about 10, 11 different bikes. So I have in the center is my sport touring bike, which I go for long distance. I go to Kentucky, Tennessee, Florida, Alabama, anywhere, also in Michigan. The top left was my favorite Harley, and the left bottom is the Ninja 650, which both my kids also ride. So Richa and me both ride motorcycles, and that is one of their motorcycles, but I also ride it once in a while. So that's and as I love the outdoors, I love hiking. I think hiking is something that also keeps me a little bit fit, because I don't like to go to the gym all the time. Outdoors is what I like. I like to feel, smell, and touch nature. So on the top left is a shot from Chadar Trek, which is up in the Leh Ladakh area. So I did that about 12 years ago. And it was basically walking on frozen river. Top right picture is about six years ago. This is a group from Detroit, all my friends here, and we did the Everest Base Camp trip, which was really epic, a great thing. And at the bottom are some of the recent pictures. On the bottom left are pictures from my South Dakota trip, where we did some hiking with friends. And the right bottom is a shot from, I don't know, 15 years ago, I think, 12 years ago. I did skydiving. So that was just before this, I think after. We all looked dazed there. So it was a great experience. We did tandem, so not solo. Tandem is where you're strapped to someone and then that person basically releases the parachute. You don't have to do it. That's how you typically do it if you do it first time. So those are some of my crazy passions. I've performed on stage. I like to really play music. I play tabla. Now I'm going to be playing tabla with a sitar instrumental. I'm not an expert, but I like to keep myself engaged and also practice, because practice makes you perfect. And these are some of the shots from the local nataks. I'm not going to, I've been part of dances and songs and theater. I love theater. As you can see, this is from the Ranangan drama that Yogesh made. On the left is obviously my shot with Saroj. Saroj was helping out the crew when we went to Philadelphia and did a show there for that Marathi Mandir. Then I had played about three different roles in that. My main role was of Raghoba, Peshwa on the right. And then the small two other roles was I was a Mawra, I was a Sainik, and I also played a Muslim robber who gets punished. So that was my small fourth role. So I really, this is a stress reliever for me, both the motorcycling and hiking as well as theater and music. It is something that really clears your minds and really gives you that happiness, which is very important. So I would really encourage all of you to follow your passions, and along with your career and family, you also, I think, should follow your passions, whatever that might be. These are some of the things we love. Yogesh and I have been lucky enough to be part of the Mandars, where we sometimes host a lot of artists. You might recognize some of the faces here. I don't have to say the names here. But they eventually, after, with multiple different meets, I think they end up becoming friends. So that is a great thing. I think we love to respect and host the artists, the talent from India that come here and present to us. So that's a way of giving back to the community. Vijay Kadamji has been a very dear friend, as well as Rahul Deshpande, and Ramdas ji also has been very sweet in keeping touch over so many years. So I really appreciate you guys giving me the opportunity to talk about my personal stuff, and just to give you a flavor of what we do here. Okay, so let's get into the main feature item here. Before that, does anybody have any questions? When I say this, when I ask questions, if there's anything, I'll wait for maybe 5 seconds and then keep going. So any questions before we get going, from a technical side or from any personal side?
No, sir.
Okay, wonderful. So let's get going. So today we are going to talk about lean manufacturing. So we're basically going to cover what is lean. Okay, I'm going to keep it very simple. We may get into a little bit more technical, more corporate kind of gibberish towards the end, just to give you guys a flavor of how lean organizations create their framework to make this successful. But first, I'm going to talk about what is lean, why are standards important, what is waste, and how does speed and flow in a manufacturing environment affect the bottom line. Some of the tools and processes I'll mention there, and then what is the production system model, right? Which is very important. How do you really institutionalize lean in a corporate environment? Okay. So lean manufacturing is also lean. You can just, if somebody says lean, which also is interchangeable for lean manufacturing. And lean doesn't have to be just in manufacturing. It can be in any areas of the company. It could be in a human resources. It could be in finance. It could be in product development. Okay, so this has been an approach that has been successful across the world for many years now. Okay, companies embracing lean are mentioned as or called as lean organizations. Really, it is an approach, a system. At the core, it's an organizational mindset towards all work done. Okay, when you say lean, you kind of understand lean is really, oh man, you're looking very lean today. You know, you're lean mean fighting machine. You know, what does that mean? It's basically, and you are looking very, healthy. You're working. There is no fat, right? So you've shed all the fat. You're lean, and that's what it means. Is cutting the fat out, cutting the waste out of the system to becoming lean, right? So it's not you have to have an approach, and you have to have a system that supports that continuously and systematically eliminating waste to add value to the customer. We'll talk about what is value to the customer, okay? But this is important. It's continuous, and it's a systematic elimination of waste, okay? So by that, what happens when you become lean? You improve your productivity, you improve your product quality, and improve your flow. And when I say flow, I'm a very high level sort of overarching flow for a corporate situation, which is also called value stream map. It's also called a supply chain, right? It's right from the beginning when you get the raw material and you make a part and make thousands of parts, and you make a product, which is Ford Motor Company's product is a car, obviously, right? And that goes to the customer, right? So that's the end of the arch, which is selling the product. And the first one is really a raw material. So right from the beginning to the end. And Yogesh mentioned about product life cycle. If you look at a product being a compressor or an engine, what is needed to really think about designing it, making it, and then using it in a product, versus the bigger picture is multiple parts like these make a vehicle. What happens when you become lean? When you cut all the fat, you reduce cost and you increase the value. Okay. So just a quick few things to sort of distinguish what is a traditional manufacturing approach and what is a lean approach, right? So in a traditional approach, managers would be the experts. They would be the people who will be telling everybody what to do and making all the decisions. In lean, employees are the experts. And when I say employees, the people who are closest to the action, okay? People who are working on the floor. It may be hourly employees, it may be people actually putting the parts on the car, or it may be their sort of team leaders, as we call them. And also these are all processes. So there is a term called process coaches. These are salaried positions, and then hourly positions are the people who actually do the job. So these people who are closest to the action, they are the experts in a lean system. Okay, managers in a traditional, they are the ones looking for improvement opportunities. But here in lean, employees are the ones who are looking for opportunities. They are the ones closest to the action. On the traditional side, managers conduct periodic process reviews. Periodic meaning it may be once a quarter, once a year, twice a year, once a month, once a week, right? Periodic. On the lean side, employees conduct periodic process reviews, but these periodic process reviews are frequent, because as they see the problem, as they see the issue, as they think about an opportunity to improve, that's when the action has to be taken. So it has to be continuous. It's not a fixed cadence, okay? So that's the next point, is only consider on the traditional scenario, we only consider improvements during periodic reviews. On the lean side, look for waste and improvements all the time, okay? A simple example, an operator notices that a part needs a certain redesign. He's putting the part together, thousands of parts on thousands of different vehicles, and he sees that it doesn't fit well, and the process takes too long. Whether maybe he's walking too much to get the part, or maybe he has to do three different things to put the part together. So it takes time, and it's not efficient, right? So he notifies the team leader. The team leader investigates the issue and confirms the claim, right? So they are both the people who are experts on the floor. They look at it, they investigate it, they say, okay, yeah, this is going to work, and they actually take the claim or the opportunity forward to the right people within the plant, and the new parts are procured, and then they replace the old part. Operation starts working perfectly, company saves time and money. Okay, so this is a very quick, simple example of how things can happen quickly. So do we need standards? You know, there are pros and cons to standards. Many pros. The only cons I can think is when a standard becomes so rigid that it cannot be changed, then that's a problem. Okay, because standards should definitely evolve as we go, as you find. So they should also be a continuous improvement cycle. So, but the pros are obviously, you know, you need to know. We talk about improvement, right? To improve, you really need to know what you're trying to improve. Okay, what is the one thing or a few things that you want to improve, and how are you currently doing? So what is my current state? So there is a current state and there is a future state. And what do I have to do in the middle to improve, to get to that point, right? So standards also identify both these things by systematically defining the best way of doing the job. So if you have a standard of measuring something, the standard of analyzing something, then it makes it a lot easier to really break down the issue, look at the opportunities, make the changes, and really make the improvement. So it's, you know, I'm kind of talking a very problem-solving methodology, and I'm not going to talk a lot about Six Sigma today. We could have another session for that, Six Sigma quality, but that is basically what it does. There's a standard, and you follow the standard, and everybody follows it. Then it becomes very easy, lean and continuous improvement. And what happens is by making those improvements, they become very predictable. So if you have a standard, you know that how much improvement you're going to make if you make that change. So it's meaning doing things the same way every time. And abnormal, if you see something abnormal, it's basically something is going wrong. It's poor quality, or a machine has failed or broken down, or there is a part shortage. So some of those things might be some of the abnormal things. Okay. So question for audience. Okay, and I would love for some of you guys to unmute and say it out loud. You know, for this being an exception, Adya, and then we can take all the questions later on. But open question for audience is, what is waste? Okay. So can someone quickly unmute and say what is waste? I want to make sure everybody is awake and engaged. So feel free, don't be shy.
So it's the unused material.
Unused material, good. Anyone else?
Sir,
okay.
We can define
yeah,
waste as yes, sir. These days we can define waste as a product which cannot be included in the cycle for increasing the productivity. So the part of the production that excludes the beneficial portion of the main production line.
Okay. Okay. Which is, that does not add value. Okay. Anyone else?
Hello, sir.
Yes.
Sir, the product that cannot be used in rework.
Okay, good. So the product, whenever you're doing rework, you're repairing something, you're fixing something, that is also waste, right? So good. Thank you for the the responses. So for everything there is a process, right? So we follow a lot of processes. Sometimes that is part of life. And there are two types of processes in a corporate world, or even in your personal life. There are processes that add value to you and to your company, and there are processes that are non-value added, right? So what is value added? Value added are the processes that the customer is willing to pay for. Those processes that change the form, fit, and function of a product. So those are the ones actually that create the part, that help directly in making the part, right? So that's the one that customer is willing to pay, because he's paying an amount, subscription, or a retail price for something, and we need to get him the best quality product as soon as possible and with a profit for the company, right? So that's value added. Non-value added is customer is not willing to pay for those processes that don't directly alter the form, fit, function, and there may be a lot of them, right? So but they are necessary sometimes to really make that happen. The important thing is to understand necessary versus value added. Okay, two different things. Value added is customer is willing to pay for it. Necessary is sometimes there's a support activities that need to happen to really finish that manufacturing operation or create that product. But what happens is the non-value added processes, they don't directly affect the end product, but they add time and cost, okay, which is basically waste. So these non-value added processes are considered waste, okay? Now, one more question, and I want more people who have not responded to maybe unmute and quickly tell me, what percentage of a traditional manufacturing system do you think is waste? In a traditional manufacturing system, if it's not a lean manufacturing system, what percentage of a traditional system would be waste? Like a lot of people have done thousands of these studies across multiple different industries and came up with a number. What do you think that number is? Just say it out. Just unmute yourself and just say it out.
30 to 40%.
Okay.
15 to 20.
Okay. 30 to 40, 15 to 20. Okay. Any more? Okay, good enough. All right. So you would think, right? 15, 20, 30, 40. So here's the answer. It's 98%. Okay. So it might be a very mind-boggling number. What it means is there are so many different support activities that you really make something a product or a manufacturing a product, but only 2% of it is really value added, which is creating the product directly. Okay, so what happens is traditional manufacturing focuses on value added products. This is the difference. That in a traditional manufacturing system, you look at, okay, well, this is happening, this is good, this is just a value-added process, let's focus on improving that. But what is happening is there are so many different non-value-added processes around it to make those value-added processes possible that nobody is paying attention to those. Okay, in a lean manufacturing, focuses only on improving the non-value-added processes, which is the waste, there's so much of waste that look at the opportunity of improvement in the non-value-added processes, because there's 90+% of processes are non-value added. So there is so much opportunity to eliminate waste. Okay. So there are 8 types of waste. I'm going to just one of the highlights of this presentation is going to be what are the different types of waste in a manufacturing scenario, right? So these are overproduction. These are movement, right? Motion, conveyance, which is another word for transportation, correction, which is you're correcting something, you're repairing something, you're reworking, not using the skills and knowledge of the workforce, which is really you're losing out on a lot of talent power, right? Over processing, you're doing more than is needed. Waiting and inventory. Inventory is basically your goods and products, right? So these are the 8 main types of waste that are identified across the world in a manufacturing scenario. And this could be also applied to a business scenario, but that's a different discussion. So let me kind of quickly go through each of those 8 types of waste. Okay, overproduction is really making more than the customer is needing. Okay, making a product before it's required. Okay, more than a customer needs is the customer, you're making, let's say, 1,000 cars in a day. Okay, the parts needed are 1,000 parts, but you have, how many? 200,000 parts in the sitting in the plant, or 50,000 parts sitting in the plant. It's taking up floor space. It's taking up labor to move the parts around in the plant, and it creates chaos. This is not just one part. There's thousands of parts that go into the car. So imagine a plant with all these extra parts sitting on the floor doing nothing, right? So that is overproduction of parts, making more than what the customer is needing. Making a product before it's required. So that is when is required, when is a product required? That is customer demand, right? When a customer demands a product, when there is an order that comes into the dealer, or the order comes directly into nowadays you can order vehicles online. So when an online order comes in, or it comes through the dealer, that is the customer demand. That's when you should really trigger the right delivery of the product, right? What does overproduction do? It prohibits smooth flow of a material. I mentioned earlier that when you make more, you have to store it somewhere, and that really affects, degrades the smooth flow of materials. It also degrades quality and productivity because it can lead to missed or lost part, damaged parts. It can lead to a little bit chaotic situation that could reduce productivity. You're not as efficient when you're doing the process, and in a way, it also affects quality. And obviously, all of this increases cost. Everything requires money, floor space, moving the parts, labor, repair work, people for labor for repair work. All that stuff needs cost. So overproduction is one of the main culprits of one type of waste. Second one is motion. It may be a motion of a product, maybe a motion of people or equipment. Apologize the spelling typo there. Product, people, or equipment, that is NVA, right? Which is non-value added. So when you say motion of product, you're moving parts, like I mentioned earlier, in the plant from one place to another. It comes at the rail dock by a rail car, or it comes by a truck, and it gets unloaded. It keeps, you're sending too much of it, and it has to be moved around. Then when you need it at the line site, which is the assembly line, then it gets moved to the line, right? As you can imagine that happening in the plant. That is all motion, extra motion that's not needed. People, when you say people are actually the ones who are driving the tow trucks or the tugs. They are moving the equipment, they are unloading it from the truck. People are also, it also looks at the workstation. So when I'm a worker at the assembly line putting a part together, if the workstation is not designed correctly, I have to walk to one end of the workstation, pick up a part, go to the other end and use a tool, and then come to the middle of the line and then install it. It's unnecessary walking, right? So workstation design is a big thing in any production system. Is how do you optimally? Also, there are mistakes made. Humans make mistake. It's how we minimize those, how we eliminate mistakes is important, right? So anything that is waste, anything that is unnecessary moved also causes some quality concerns. Another example is overhandling containers, right? So you are, like I said, you receive a part and you move it multiple different times, way more than it's needed. The ideal situation, if you can imagine, it's a plant factory with 4 walls, and you're receiving a part at the truck dock. Okay, the dock is where you unload the pallet, right? You take it directly to the line. It goes directly to the line, and the worker uses the same hour or that same shift or that same day. That is ideal, right? it should not be going from the truck dock to the warehouse, to another small warehouse, then coming close to the worker, and then going to the workstation. Okay, that is too much movement. So motion is another type of waste. The third one is conveyance, transportation, storage, and handling, which is exactly what I just talked about. Is even for transportation, look at it outside the walls of the factory, right? So let's say the part is coming from a supplier. Okay, it is. Let's just take its instrument panel, the dash as you call it, right? So it's coming from a supplier, and then it's going to 2 different places before it comes to the plant. That is again waste. Why don't you plan it correctly according to the schedule? Send it to the plant just in time. Okay, so your transportation time is reduced, your transportation costs are reduced, and that cost goes down. From the supplier, the cost benefits go to the OEM, which is in this case Ford, and then from Ford, when it costs less for Ford to make the car, they can, to the customer, they can offer more for the same price, or they can offer that product at a lower price, right? So all these cost benefits are not only ending at Ford, but also going to the customer. And by customer being happy and getting a product at an affordable price, they are going to keep buying from you, right? Obviously, assuming the quality also is there. So transportation, what happens is when you move it too many times, you have to store the parts somewhere. So basically what is happening, you're overproducing, you're moving it too many times, and you're really causing a lot of unnecessary work. And so that's the handling of the parts, right? So it deteriorates quality, and it also could lead to damage or loss of parts. When there is too much of something, there is bound to be some mistakes, there's bound to be some lost parts and some damaged parts. So that's again cost. Okay, so conveyance or transportation is the third waste. Fourth is the correction, which is basically very easy to understand. It includes rejects, rework, and reruns. Okay, so and when you have a reject, that means your quality first time. So there's a term called throughput, or we call it FTT, which is first time. Is the car made perfectly the first time? Okay, what is the percentage? So it's a very big important metric that Ford as well as a lot of other OEMs look at from an assembly plant, as what is the FTT, which is what is the percentage that a product is made perfect the first time. So it doesn't have any quality defects when it comes off the assembly line. Okay, so that is when that happens, it goes to the repair bay. There is a repair person who works on it. Okay, that's rework. Okay, and sometimes back the vehicle to do some last minute checks, which are called end of line checks. There may be electrical checks. There may be roll tests where you check the vibration and roll off the power of the car. They also check all the electrical stuff, because nowadays the cars have become computers. There's computers in there, there's technology, and you need to run that. So that's a rerun. So look at if you can imagine it, you're not having a perfect process. So you're causing quality defects, which is rejecting the vehicle. The vehicle goes to the repair bay, it's reworked there, and then it has to be brought back to be rerun. And then again, once all the quality defects are fixed, then the car goes out of the plant and to be shipped to the customer, right? So that's correction, and all this, as you can imagine, takes time and money. Okay, and associated costs are really storing inventory, reinspection, rescheduling. Everything needs manpower, everything needs tools, and everything needs money. Okay, so the key mindset is basically, as we call in manufacturing at Ford, is zero defects. Okay, zero defects, not 5%, not 2%, zero defects. Okay, that should be if you have that mindset, you will not accept any defects. You will go after every problem that you're having and really make it zero, right? So that should be the mindset. So correction is a really big waste. workforce utilization is very simple to understand. Is not using the skills of the workforce, not using the knowledge of the workforce, not understanding who is working for you. Okay, sometimes there are people, and it goes back to the lean approach, as I mentioned earlier, the traditional approach versus the lean approach, where all the managers make the decision. They are the ones who are calling the shots. But in a lean organization, the workforce is given is asked the question. They are given the authority. They are given the encouragement to really come up with improvement ideas, because they are the ones who are day in and day out. They are putting the parts on the line. They are seeing the tools. Maybe it is a part not designed correctly. Maybe it is a tool that is not working correctly. Maybe it is a process that is not working correctly. Maybe it is a bureaucratic process, really driven by the higher ups. That is really causing a lot of slowing of the process. So what it really means, workforce utilization not only is using the right people at the right job, but it's also giving them the authority. And how would you utilize them to really add value is really utilization. Over processing, which is again very simple to understand. I already probably talked about it. It's customer is not willing to pay for the non-value added process. Double and triple checking something, double and triple processing something, not making the process optimum. Those are more touch points, and that leads to more opportunities for failures, more opportunities for things to go wrong. Right? A simple example. In an office situation, having meetings to discuss other meetings. Why? Okay, so meetings to discuss a meeting which is going to be presenting. Meeting, right? If your process, think about it. I'm going to put it back on the VJTI ASME student group here, right? If you think that this whole process of getting guest speakers and doing this is maybe eliminate a step and make it more direct, quick, and effective, then do it, right? So then you should also voice your opinion about that. So it could be as simple thing as making less meetings. It is also creating multiple inspections points when not needed. Okay, it's more of a manufacturing scenario. So over processing is also bad. And then waiting is obviously, I don't want to explain what that means, but waiting is where the parts are made, they are coming there, and they are doing anything. They have been produced, and they are just sitting on the floor, and nobody is using all the parts that have been received, 2 days ago. So that is waste. A machine that is operational. Let's say there are 3 presses in a stamping plant. A stamping plant is where you make the sheet metal of a car, for example, the roof, the hood, the side fenders, right? So that's a stamping plant. So size of a building presses that create those parts and blanks, and they are all running, but there's not enough material to really make the parts. So that's waiting. So that's not good as well. So correct scheduling of the parts is important, and what leads to another process. So there is a input to a process, and then there is an output of one process, right? So that's process 1. Process 2 would have the output from the process 1 as an input to process 2. And then the process 2 happens, and then you have output number 2, right? So that can keep going on. So that it's because it's an assembly line. So the idea is to link the output of the previous process to the input of the second process, the following process. What it does is really it schedules the understanding how much cycle time. If you might have heard the term cycle time, which is understand that, then you can plan the inputs, then you know how much exactly that process is going to take, and you will have this output at this time, then you feed it to the process 2. So if you schedule it correctly, and a lot of industrial engineers do this type of work in a plant situation, that if you correct scheduling of parts and machines is important, and that eliminates waiting. And inventory is basically another word for excess material. Is your goods and products that are sitting. It could be cars sitting inside the plant which are to be waiting to be fixed. It could be cars sitting outside the plant walls ready to be parts like engines and dash, or a trim panel, a seat. They're waiting in the either at the supplier warehouse, he has like stock of it, or it's sitting somewhere inside the assembly plant, just taking up floor space, right? So this is inventory, and everything costs money. If the inventory is sitting inside the Ford Motor Company four walls, Ford Motor Company has paid for it. Okay, if the cars that are made, they are waiting for repair, that is hurting Ford, because they are not getting the money from the customer, right? So the ideal thing is to pay for the goods when they are needed, and then make the product, and send it and sell it immediately. Because when the trucks or the cars leave the walls of Ford Motor Company and get on the rail car and truck going to the dealerships, that's when Ford Motor Company gets paid, right? So the idea is to have the optimum inventory, the least amount of inventory that is needed to run the operation effectively. Okay, and that is all starts with customer demand, understanding what the demand is, and then planning everything accordingly. Okay, and when you have excess inventory, what does it do? It hides problems. It increases the lead time, and we'll talk about what lead time is. The lead time is the time taken from the start of the process to the end of the process. Okay, it also consumes production space, warehouse space, floor space, ties up money, as I said, and then creates more waste. So excess inventory is not good. Inventory is good, but inventory leads to waste when it is excess. Okay, and WIP is basically work in process. So work in process is something that it's being processed. It's it has started at this end and it's going to be ending at this end. There are multiple different processes it has to go. So that's when we called it a work in process. So material is the raw material that comes in, the raw parts that come in, and then work in process is when, like, for example, an assembly situation would be you're making the car or the truck, and then finished good is when you actually have a end product, a truck or a car. So how do you eliminate waste? And I actually give you the answer here. By removing it whenever it is identified. So that is the continuous improvement mindset that you have to have. Is how do you eliminate waste is as soon as you see it, you start working on fixing the problem. You don't wait. You don't wait for periodic reviews. You don't wait for some of the managers to come and tell you that this is a problem. It actually also puts the onus on the people, and that's where the understanding, utilizing the workforce, giving them the power to speak up, that all comes into play. Is when you ask them to make the decisions, when you ask people who are closest to identify the opportunities, that's when you are most successful in a lean organization. Okay, and by removing it, it's whenever it's identified, also by eliminating the root cause of the waste. Okay, so by eliminating waste, you just don't put a band-aid on something, right? Don't do a short-term fix. You think about how do I make it a fix that sustains. That is important. Simple. So what happens when you have a flat tire? Okay, to have a flat tire, there is no air in the tire. You put air in the tire and then you start driving. That is just fixing the problem because there's no air. Let's put in air. But then if it happens again, what is the fix? You have to really take the tire and fix the hole. Take out the nail that has gone inside the tire. So going to the root cause of the problem is the important. And going to the root cause will help you eliminate the waste more effectively. So ways to eliminate waste in three simple ways is prevent. Is first of all prevention. Best way to eliminate, right? Design it out. You basically, if you see something, how do I change the design? How do I change the process, manufacturing process? And how do I error-proof it? So error-proofing a design and is basically designing a part that it cannot be assembled in the wrong way. Okay, so there are some features you might, some of you guys might be in the design area. You might have taken some classes, but error-proofing design is a big thing in making sure that it's basically, it's called idiot proofed or foolproof, right? So nobody can put it even in their sleep or with their eyes closed in the wrong way, because it is designed such a way that it will only get assembled in a certain way. So that is designing it out and error proofing it. Okay, combining some things, combining two activities to make it optimum, looking at efficiencies. When I say efficiencies, what has to be done to make the process more efficient is looking at those efficiencies and making combining some process, or optimizing them. That is how you reduce waste. And then simplifying it, eliminating anything that is not necessary. Okay. So two concepts. Say, yeah, of course, speed means going faster, but in this case, it's not about working faster. You don't have to do something fast necessarily, but reduce the lead time. So what is really lead time? As I said earlier, it's the difference from the process start to the process end. Okay, and when you eliminate waste, identify the opportunities to work faster, which is eliminate the waste elements within that process start to process end, then you make the process end earlier, right? So you're shorter lead time, and then you have the waste reduced. So that is speed. You're reducing the lead time for something. Another example of lead time might be, just to give a very high level overarching example, is you heard Yogesh talk about product life cycle. Life cycle is from the start to the end, right? So what is the lead time when a company decides, okay, I'm going to make this 22 model year, let's say, a Mustang, right? And they start the process way early, 4 years ago, 5 years before it's actually going to be 2022, right? So that is the lead time taken by Ford Motor Company to start the process, and end the process is when you actually make the first 22 model year Mustang, right? So what are companies looking at? How do I reduce the lead time? How do I make it a very efficient process where all the fat is cut, all the waste is gone, and we can deliver the product to the customer faster, right? Let's cut it down from 5 years to 4 years, 4 years to 3 years. They're creating these vehicle life cycles from start to the end. Okay, so smallest operation in an assembly plant, and then looked at it. Okay, how do I improve my lead time? How do I make the process more efficient? And flow is obviously how things are moving. You guys are familiar with process flows. Customer demand. Customer is God. Customer is the ultimate, because he or she is paying for what you are producing, whether it's a product or a service, right? So system should flow at the rate of customer demand. That's when it becomes most value added. Okay, suppliers in the assembly situation are upstream. When I say upstream, is imagine a stream flowing, right? Upstream is at the beginning of the stream, and as it flows down, that's downstream. So suppliers are at the beginning of the value chain, and the material is flowing in a certain way, then it's getting the customer. Okay, so if you can imagine all the previous examples that I've talked about of receiving parts, making the car, and your value stream map, right? So that is a methodology, that is a tool, it's a skill set of really working on value stream mapping in organizations like Ford. And what we have to look at is in flow perspective is push and pull systems. Okay, and I'll talk to you about that a little bit more. Push system is where you are pushing the material, and you're making material and you're sending it to the plant. Making and sending it to the plant. You're not thinking about how much the plant needs, what is the customer demand. You're just kind of overloading the plant with material. And we talked about inventory. And pull system is where you're starting at the other end. You're looking at the customer demand and only pulling what is needed. Okay, I only need to make this many parts, and in this combination, so I need this many parts of X parts of this, Y parts of this, and that's how I make my production for the day, right? And you should keep as less as optimum inventory as possible to really make the product. And production scheduling, this all is scheduling. This is understanding what the customer demand is, how do you schedule the products, and how do you schedule all the different things that need to come together. And also need to look at cause of waste. So when you have a flow, when you have a process map in front of you, you can identify the bottlenecks. Bottlenecks are the hurdles or the areas of opportunities that are causing stoppage, they're causing quality defects. So those are some of the, you can identify causes of waste when you understand the flow correctly. And it also, what it does is it prevents abnormalities. So when you have a very clear way of looking at things, you can understand what is the normal way, or as we called earlier, standard, right? So if it's a normal standard, when something goes wrong, that's an abnormality, you will immediately pick on that, right? So that also is prevented by understanding flow. So I want to talk about push and pull system. Is basically product is pushed ahead by individual schedules. Like there are individual schedules that people are managing. Okay, well, this supplier is just sending tons of data, or not data, but material. This supplier is sending pallet loads of parts to the plant, and they have no idea what Ford needs. Okay, they're just working on their own. But pull system is product is pulled ahead by individual schedules. Again, on the push side, materials are overproduced. You have more than it's needed. And on the pull side, it is nothing is produced until the downstream process needs it. So as I said, the downstream process is basically the customer, right? And it has to start reverse. It cannot start by making product and pushing it. It's basically understanding what the customer demand is and using a pull system. So in a push system, you are delivering and you're making the parts all the time. And in a pull system, you are making the parts and delivering the parts just in time. So I gave you an example earlier of a part coming at the truck dock and directly going to the line. That is the ultimate, ultimate situation, right? That is called just in time. And it's a big, just like Six Sigma and Lean, just in time is also a big methodology on how to do that, right? So a push system creates waste and hurts the optimum flow, and pull system, it eliminates waste and improves the flow. And again, I talked about scheduling, which is how do you plan the production? How do you understand the demand and plan in what order, how many, and how often, right? So these are simple 4 things that scheduling really looks at. So prevention of abnormalities, and really they occur when a standardized process is not followed. So if you don't have a standard, or you don't have a disciplined process that everybody follows, then abnormalities can happen. And I would call it, I don't want to go into deeper Six Sigma, but those are normal basically defects, okay? When you have a standardized process. And when abnormalities are, when you understand what your standard process is, when abnormalities happen, you can see the, if you track metrics, if you see what your, when you measure something and you see the chart, and if something abnormal happens, you can immediately detect it. So that happens when you have a standardized process. Preventing abnormalities is more effective than fixing an existing problem. So because you want to reduce the abnormalities to 0. Okay, so no abnormalities is normality. Like I said earlier, it is lean manufacturing as outside manufacturing. Okay, it may be design engineering. It's designing it right, error proofing, as I said, operations and engineering, where you're reducing waste and scheduling it right. IT. Okay, we talked about the flow of not only materials and product, but also data, information, right? So IT systems in a manufacturing environment, for example, you're looking at old data. You have data in charts from a week ago versus real-time data. What am I producing right now? Where is the, how is my, there are multiple lines within an assembly. I am not going to get into assembly layout here, but there is a body shop department. There is, the body comes into the paint department, the body gets painted, and then the painted body comes to chassis department. And then all the chassis parts get assembled. Then it goes, as you can imagine, body shop, paint, chassis, trim, final. And then it goes. The more real-time data you have, the better you are at fixing it and eliminating future problems. And for that, sometimes you use process control boards, and you'll see those everywhere if you go into an assembly plant. And I would encourage you, if you get an opportunity to go visit an assembly plant, any industry, whether it's automotive or any other aerospace or anything like that, to understand what that means. And then to be able to control a process effectively, you need to have real-time data. The real-time data is shown on the process control boards. That's when you quickly see the red flags. That's when you quickly see that what are the biggest issues you're having and how to fix that. Okay. And then HR, human resources, just a very non-technical area. You can apply lean, finding the people right for the lean culture, providing appropriate learning and development. So those are some of the examples of lean. Okay, so I'm going to now transition into just giving you a quick, I'm not going to go into depth here, but some tools and processes that we have already talked about, or there are some that, these are just some of them, right? Problem solving is using a methodology, a standard process to solve issues or solve problems, quality defects. And one example is, using a Kaizen methodology, using Six Sigma, right? Using data, basically. What is Six Sigma? Six Sigma is basically having very, 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 very high quality, right? So the defects are not even about 1%. That's how good your process should be. And there is a methodology that we make, measure, analyze, improve, and control. DMAIC, right? That is a very well-known kind of methodology. And then DFSS is designed for Six Sigma. So a very simple distinction of that is DMAIC is fixing an existing process. Okay, so you have a process going on and I need to fix that. There is a lot of waste, there's low-hanging fruit. You go and fix it, right? You look at the process, you analyze it, you take data, opportunities are identified, you make the changes, and here you go. Before data is showing this, after data is showing an improvement, right? So you have the existing process, you're not changing anything, you're just changing some elements within that process to make the process more efficient, higher quality, right? A DFSS is when design for Six Sigma is when it's already been optimized. It's already, you can't really have any more quality improvements. That's when you go into designing. You go back to the drawing board. You're going back to the basis of why you have the part and why what your issue you're having, and redesigning the part. So that is where DFSS. So those are two sort of streams within Six Sigma. And Six Sigma is just one of the problem-solving methodology, okay? Visual Factory is basically having everything visual. Like, I'm going to touch upon a few here, not every one of them. But Visual Factory is, you can imagine a plant floor, and there is a line going this way, and there are parts that are stacked up on both sides of the workstation, because that's what goes into that workstation, right? But there are piles, like there's pallet, and then there's a pallet on top of that, and there's a pallet on top of that. And you can't really see anything. The people cannot see what's going outside the plant, what's going on outside the line. They cannot see any process control boards, right? So that is a hindrance to how factories run. So the new lean methodology is have less parts, only look at what demand is, schedule it accordingly, and have the least amount of part in the plant. So what it does is it really opens up the view. You can see problems happening quickly. You can identify and go to the problem quickly, okay? Another very simple example is Visual Factory is having the operators, training them correctly to do the job, but also having them a visual, it's called an operator instruction sheet in a manufacturing environment, a OIS. It's maybe a different term in different companies, but it's basically a very visual thing of these are the different parts, and this is how I'm going to be assembling that. This is the tool I need. This is the torque I need for the tool. And these are the different screws that I'm going to be using and torquing them to this thing. This part has to be aligned in certain way and assembled. All that information is given to the operator right at the station. Okay, so that's Visual Factory, giving them a visual picture. And what happens is that process gets done. the same way every time, right? What also happens is the plant may have different shifts during the, there may be a day shift, there may be a night shift. There may be people who go on vacation and a substitute comes to do the job. No matter who is on the line, whether it's a day shift worker, night shift worker, or a substitute, they're always looking at the same operator instruction sheet and putting the parts the same way so that there is standardization and the defects are less, right? So that's another example of visual factory. And workstation design, I think we talked about designing at optimum, so the walking is less, it's more effective. Quick changeover, that's an important one. And we talked about waiting, right? Machines waiting. Machine is running, but nothing is happening. So quick changeover is when you are switching a machine from one operation to another, which is, let's say example, I talked about stamping dies, stamping presses. There is a die that creates, let's say, a door fender, right? The side panel of a door. And then the same press has to start making a roof, right? So the die has to be changed because the plant cannot have 20 different presses. It may have 3 or 5 presses, but they have to change the die inside the press to go from a door fender to a roof, right? So they have to change it. Now imagine what would happen if the changing over of the dies took 2 days, right? That would basically make the process very inefficient. Parts will be waiting, and there will be a lot of inventory, and so this is all waste. So when you have a machine that needs changeover, should be quick, right? So everything should be quick. Basically eliminate all the waste. And we talked about error proofing earlier. I'm not going to talk about more. It's designing it out, making it foolproof, making the process such that it is automatically made idiot proofed and given everything that needs to happen so the errors are minimized or eliminated. Process mapping, I talked about the value stream mapping, and these are some of the processes that are, when you have a process mapped out in front of you on a sheet of paper or a computer screen, and you understand what needs to flow, what is my customer demand, how many trucks should I be making at the end of the trim line, at the end of the finish line. You understand what the flow is. You can identify where the issue is happening, where the failure is happening, and you can go directly to the line. So that helps when you understand the process flow. You understand a process flow in such a way that it's not just a picture, but it has data. It has the cycle times. It has the throughput. It has the jobs per hour, right? What is the process is what you understand by doing process mapping. A work analysis sheets is I mentioned about the operator in a pre-assembled number of parts that becomes a kit, and you assemble it. So you don't have to do it yourself. It's already comes directly ready for you, and you put it in the car. A very simple example I'll give you is a door panel in a car, right? So it has the glass, it has the handle lock and locks and mechanisms, right? And it has the speaker inside, right? So just to name a few, but there are other parts. Now imagine an assembly plant putting all these 20 different parts together. It'll take a lot of time. It'll need a lot of space for that to have that sub-assembly, and then you put the door panel assembled in the car. Now imagine the second option, where a supplier is putting all that together, is kitting that for you. So he may within a plant in a corner of a warehouse, or they may have a facility somewhere outside the plant. So they may have their own facility. So they get all the different parts, they kit it, they assemble it, and it's called a sub-assembly. The sub-assembly gets shipped to Ford Motor Company directly. So all the operator is doing is going to the rack, picking up the sub-assembly, going to the car, putting it inside, running 4 screws, done, right? So what is the more efficient process? The second process, because yes, you're paying the supplier to assemble it, but what is happening, at the end of the day, you're probably requiring less labor at your plant to put it together. That is being put very systematically in a disciplined way. Error is less. All the quality defects are already being caught at the other end, and you are getting all perfect parts. I mean, when I say all perfect, and 100, but very close to perfection, right? you're getting it, and then this is cutting the waste out. Okay, so kitting helps with that. And then we talked about pull system, and preventive maintenance is very explanatory. It's not breakdown maintenance. It's not you go and maintain a machine when it breaks down. Yeah, of course there are failures that happen without any prior indication. That is life. But how do you design your maintenance system such that you have preventive maintenance in place? Is you know what the life of a machine is, the life of a part is, and you go and replace that part, ahead of time. Okay. Another way of looking at it is also predictive maintenance. Is how do you predict the maintenance schedule for a certain machine or a tool, right? So there are indicators nowadays where, let's say, for example, a robot is working, is picking up a part and taking it and assembling it. There is a machine that is machining, drilling something, welding something. And when you have sensors there that detect vibrations on a machine, okay, that will tell you that, hey, you know what, the machine is showing me a vibration trend that is abnormal. It's not standard. It's out of the blue. That means there's something happening. Maybe a bolt is loose there, or the machining tool is wearing out. It's not doing its job. That's why it's creating more vibration. So nowadays, there's a lot of these different things that can be done to really do predictive maintenance. Okay. So those were some of the tools. I just wanted to touch upon a few here. And really, what are the steps to becoming lean? Is really adopting, stabilizing, and continuously improving. So what does adopt mean? Is really adopt and internalize everything that you talked about becoming lean, reducing all the different types of waste, and keeping that mindset all the time. It's not like just fixing it once in a while. It's fixing it when you see it, all the time. Stabilizing is once you make the improvements, how do you stabilize? How do you sustain those things, and then continuously improve in the same way? Okay, so basically, a lean production system can be defined as a system that focuses on flow. We talked about flow to shorten the time between the customer time. So not only flow, but lead time, and by addressing sources of waste. So when you cut the waste out, the lead time is short. Okay, to put it in very simple terms. So 4 lenses of lean. I'm kind of going into a little bit of putting everything that I talked about in a really very simple, easy to understand manner. Is standardization. We talked about standards, but there are inputs to a process and then there's outputs. If you are to make the input standard, the process is standard, and the output standard. Okay. And there are also times when you have to change the standards. That happens when there is a completely new product happening. There's a completely new tool that's coming in. There's a completely different way of looking at a process, right? So that's when the standards also change. But when you change those, make those changes, and again, that process then becomes standard. That input then becomes standard, right? Eyes for waste. What that means is really you have to look at it from a daily perspective, right? More eyes, everybody should be looking for waste, not only just the managers and the engineers, but everybody that is down to the hourly worker on the line, the team leader, the engineers that are running the floor, right? They are the ones that, so more eyes you have to detect waste, more will be found and more will be eliminated. And what will that do? That will make you more lean, and that will create more value, okay? And performance is to be understanding how you're improving, how much you're improving. You have to understand the performance, and which is basically what measure the process in a certain way. You have the metrics, you have the objectives as a trim line, as a assembly plant, as a company on the whole. Okay, everybody runs by metrics and objectives, right? So if you don't have metrics, you don't know how much you're improving, whether you're improving. And how do you do it? It's basically a very simple methodology. I won't again go into that in detail. It's called PDCA. It's plan, do, check, and act. Okay, so it's planning what you want to do. It's actually doing it after you do the proper planning. And then after you do it, you check how you're doing, right? So you check your after performance, and then you act on it, right? So if you check, if you see something, you act on it. And again, that cycle continues. It's PDCA. That's the cycle of continuous improvement. Okay, and nothing but endless pursuit of perfection. Don't wait for tomorrow. Don't wait for anybody else. Today and now is the time to improve your performance. Okay, so continue having an endless pursuit of perfection is what continuous improvement is. Okay, so I have basically talked for about an hour, I think. I have a few more slides to go. Any questions? Are we good to go in terms of time that everybody has? I would put that to the hosts that are online.
Yes, sir. We'll be addressing questions at the end of the session.
Okay.
So you can continue.
Great.
Adya, how much time do we have? Is everybody flexible?
We can continue with the session for 10 more minutes and then we can move on to the question answer part.
Yeah, okay. Because question answer is going to take half an hour or more, for sure.
Okay. Sounds good. Okay, so I will get going. I will target 10 minutes. And this is again a small part. I am going to, it may be, but I think it should be understandable if you've been following what I've been talking. I think this should be understandable pretty easily. Now, I wanted to kind of go from what is lean, what is waste, what is continuous improvement, to what does the company like Ford has to do to really internalize the production system and use that approach and basically cascade it down across the enterprise, right? So manufacturing strategic approach, what is lean production system? It's a manufacturing strategic approach that includes the right leadership behaviors. That is important, okay? Because it starts from the leader in terms of setting the culture of a company. Okay, so that the leadership behavior has to be right. You have to have the right operating systems, and you have to have the key unifying processes. So key unifying processes I'll talk about in the following slide. And that's supported by an aligned and capable organization. You're having the right workforce trained properly with the right skills and tool set to deliver best in world results. So there's a lot of different things here, right? You have a strategic approach. You have to have the right behavior from the leadership. You have to have the right operating systems and framework. You have the right key unifying processes that kind of talk to each other. And then you have to have an aligned and capable organization. And that's when you really get best in world, best in class results, okay? It's about delivering business results, about identifying, eliminating waste, standardization, continuous improvement, clarity of roles and expectations. All the employees should understand what their objectives are, right? Starting from the CEO of the company, all the way down to the person on the line, right? There are about 20 different layers there, but understanding, having clarity of role for you, for your department, for your management, for your factory or company, that's what we're talking about. And it's about the people and the culture. And it's integrating, streamlining, and removing waste from the standards expected, right? So why is this important? We already talked about it. I think it's just a regurgitation of why it's important. It's ingraining a zero accident culture regarding safety. Now, I will touch upon a little bit of the operating systems that are within a production system. But in a safety, if you look at what is the most important thing when you're looking at safety in a manufacturing environment, it's accidents, right? There are sometimes, unfortunately, cascade the standards from, let's say, North America to Asia Pacific or Europe, right? Or any other region that companies might have. Again, providing clear roles and responsibilities to the people, providing an integrated system. So when you say something to the people, do this, you need to give them the tools and processes. You need to give them an integrated system that really ties everything together, and then driving continuous improvement, okay? So goal is obviously have year-over-year improvement for a company. What is that? That is very important. And that will only happen through operational excellence, and which is basically when you have a lean organization, when you have top-notch quality, we have very good profitability, and you have a continuous improvement mindset. That's when you really become gain operational excellence, and you become best in the world. Now, I wanted to show this is just a quick picture. And if you see the small little boxes inside the bottom rectangle, there are safety, quality, delivery, cost, people, maintenance, and environment. Okay, so energy also goes along with the environment. So these are the main willing to bet for most of the manufacturing companies. It's safety, quality, delivery, environment. Okay, and of course the another thing that is not put down is launch. Launch is also very important. How you plan the launch and make the product. That's important. So these are some of the operating systems within your production system. Okay. And the leadership, as we talked about leadership behaviors, that's very important for it to start from the top, so that the culture of the company is changed. Standards are standards. Understand what the time and data management is, which is what is your schedule, what is the calendar, or how is a plant manager spending his or her day, how is a area manager doing it, what is the cadence required plant level, right? So that's important. That's important. Having an organization that really understands this, understands what the high level objectives are, and are aligned with the leadership. If everybody is in agreement of the objectives as well as how things should be done, what standards to follow, and what is my expected, or what needs to be done at my end, and how do I continuously improve. And just a couple of examples from couple of operating systems. One is the people, is commitment to our people and team, and investment in the whole person, our teams, and how we work together. How are you doing in your current role? Okay, what skill sets are you using? How do I improve? And also career progression. How do you get throughput or the metrics that are needed at my facilities for my equipment, right? So there's a quick couple of examples. Then we talked about time and data management. Policy deployment is really, on a very corporate basis, is what policy, you make the policy and you basically cascade it down, you deploy it down to the different levels. And that's all about policy deployment. Standardized work is, we talked about it, which is basically nothing but if there are abnormalities, you identify those and you improve those. And once your process is fixed, then you confirm the process. So process confirmation is a very regular activity within a lean organization. Okay, so these are some of the key unifying processes, and I won't talk about this. I just kind of explained that. This is just an example of a charter, right? You said standard, and I talked about DMAIC, the Six Sigma process. So that's one of the tools used for problem solving. And so imagine this slide as a charter. The one page or the opening slide or the main charter for the project would be right, and then identifying, doing the fishbone diagram, breaking it down, looking at the process map. All these things are tools to analyze and identify opportunities. When you look at the opportunities, you prioritize them and you make improvement actions, you improve them, and then how do you control the actions you put in, which is how do you make it standard, how do you make it sustainable, right? How do you control the process? So that's just a quick overview of one charter within a problem-solving methodology. And then this is an example of a time and data management. What does the calendar look like? This may seem trivial, but it's very important how you spend your day, whether it's a vice president, whether it's a director, whether it's a manager, whether it's an engineer, whether it's a team leader on the line, right? It's a standardized, disciplined cadence of activities. If everybody follows that and supports that, then you will have good information, data coming in, you'll have good discussion and problem solving happening, and you're cutting the waste out quickly, right? And thus leading to continuous improvement. And aligned and capable organization. It's basically, organization where people are engaged and motivated at all levels, that not only improve system stability, but also make capable processes. And really, that's the foundation on which you build your processes and operating systems. Okay, so that's important to build, and that's something that I just mentioned here. And really, cultural aspects is a big thing. How do you set the culture up? Whether it's being diverse in your background, in your ethnicity, in your experiences, but also culture in how do you manage your day-to-day activities? How do you set the tone for roles and responsibilities and positions, and designing and mapping all the roles and so that's an important thing of understanding what my requirement is from a human resources manager or a plant manager or a director of manufacturing, let's say, we always look at what is the skill set that I need in a plant, and what kind of skill set and people am I hiring, and what are the different tools coming in the future. How do I need to train my organization and the people at different levels? What are their competencies, and how do I make them more competent and talented? Okay, so that is in a quick way making an aligned and capable organization. Okay, and again, leadership has the responsibility.
Excuse me, sir.
Yeah.
We are actually running out of time. Is it possible to wrap it up sooner?
Yes. So this is, I think, this last slide. So
okay,
yeah.
Thank you.
So basically, leadership has the responsibility to articulate the vision, understanding what the vision is, and really follow that vision, follow those behaviors, become a model for your people, and making everybody understanding the objectives, engaging them at all levels, and then implementing it, ingraining the zero defect mindset, becoming teachers, and leaders can be teachers as well. And so by really implementing all this, that's when you really have a successful lean organization. Okay. So with that, I conclude my presentation and open it up for questions.
Thank you, sir, for such a profoundly enlightening session. The audience has a lot of questions. So with your permission, I would like to begin with the question and answer session.
Absolutely.
Okay. The first question is, which types of organizations use a lean management system?
All types of organizations use a lean. Like I said earlier, it is not just limited to manufacturing. It can be, what I'm saying is not only just automotive, but any manufacturing, whether it's automotive, whether it's aerospace, mining, heavy machinery, space, but it's also not just limited to manufacturing. Lean can be used in a business environment. It can be used in a finance company. It can be used in a HR, human resources setup. It can be used in a government relations setup. So lean is methodology. It is not limited to manufacturing.
Okay.
Hey, Prashant, I would want to add to that. My wife was just going for grocery shopping right now, and she said, "What do you want?" I said, "What is the inventory? What is the process?" So basically, what lean manufacturing is, you can implement lean manufacturing within yourself, within your anything. That's what it is.
Great example. Yeah. So understanding what you have and what you need.
Yeah.
It can start in your kitchen, right?
Yeah.
Good example. Yeah.
Okay. Great example.
I think I would say both, because people are the ones who are actually doing the processes, and having and really arming them or equipping them with the right processes is equally important. So you have to have the right people in place, have an aligned organization, and also have very and sustainable processes. So both is important.
Okay. How large does a company have to be to practice efficiently in manufacturing?
There is no one true answer for that. If you have a manufacturing operation, doesn't matter how small or how big your operation is. It's how you set it up. It's how you look at your value stream, how you look at process map, and how you identify waste. Okay, if you just employ those 8 different waste methodologies and look at whether I'm over processing, whether I'm waiting, whether I'm doing rework, if you just go through those simple things and it starts at you start at Gemba, as the Japanese say. Gemba is actually the site where the operations are happening. So it all starts off at the lowest, the starting point of where the things are manufactured. So the size of the company doesn't matter.
Okay. You talked about non-value-added products. How do we lessen or eradicate the occurrence of such products in a manufacturing process?
So that is, again, if you look at the waste, non-value-added processes are all the stuff that we talked about: over processing, over motion, conveyance, repair. All those elements of waste are non-value added processes. If you look at a process map and break it down and understand what is the, am I touching the part too many times? Am I doing this in a very non-efficient way? That's how you break it down and reduce the non-value added processes.
Okay. How does lean management actually help make a good workspace environment and ecosystem?
That's a great question. I think when you are thinking lean, you're not only making it very clear to the organization that, hey, these are the objectives. And when you have clear communication from the leadership to the people, hey, you are the person closest to the action. What do you see that we need to improve? Asking their feedback, giving them empowerment of making decisions also, that actually improves the employee morale a lot. You feel like you're giving them ownership. They feel part of the company. Okay, whether it's an hourly employee, whether it's a salaried engineer, whether it's a high-level leader, by giving them the right decision-making power and listening to their feedback and implementing those actions. So you're becoming lean, but you're also keeping the employee workforce happy.
That's an interesting perspective. Next question. How can lean affect the supply chain?
So lean, yeah, of course, there is going to be a repercussion, right? So if you create your lean principles, your lean standards, your lean objectives, and you cascade it back to the supplier saying, hey, supplier number one, I just need 200 parts to be sent to me every day. Okay, don't send me any more than 200. I'm not going to accept those, for example. So the supplier can then plan their facility to make only, let's say 250 parts, so they can send 200 parts to Ford, right? So what it does is makes everybody more efficient. And that also leads to them needing less labor, them needing less parts at one time, right? So all these things are a cascading effect in making the whole value chain lean.
Okay. Next question. How can we eradicate existing plastic waste without actually increasing the carbon footprint?
Reducing the actual plastic waste without, can you repeat the question?
How can we eradicate the existing plastic waste without actually increasing the carbon footprint?
So I think one quick way of doing it would be recycling, right? So reusing material and that's why it's important for us to recycle and follow the standards that have been laid down by either our government or by companies or in general society, that if you follow those, then you are going to keep the same plastic being recycled. And so you're not increasing the carbon footprint, but you're kind of reusing the stuff and recycling it. And that's why giving back to the nature.
Absolutely. Similar question. What preventive measures can one adopt through lean management to reduce one's carbon footprint?
So basically, if you're looking at the carbon footprint, you have to break down that process, right? What is leading to what are the key indicators of that your carbon footprint is going up? What are the processes that are leading to higher carbon footprint? If you look at those processes, those inputs, and break down the process, and then again apply those 8 waste things of lean, that's basically how you are going to break down understand what is causing the higher carbon footprint. How do I improve that? Now, I talked about 2 things. One is improving a current process and redesigning a process. So if you think that you've already improved the current process to the max, then you have to completely think about redesigning something on a bigger level, which will then making it a lean process and then reduce your carbon footprint or not make it worse.
Okay. What approaches can one follow to reduce lead time?
So that is a great question. One thing of doing is current start process to the end process, right? So I just basically had a very simple thing. I had two boxes joining the line. But what in reality, there's multiple different processes happening from the start to the end. If you understand what your value stream map is, if you understand what your process map is, if you understand what is expected from each of those, for example, processes, if you understand the cycle time for each process, then you will understand, almost have a checklist of those 8 waste items and identify, okay, you know what, I'm over processing here. I am having rework here. I'm waiting time here. I'm not conveying. I'm not transporting the material correctly, right? So if when you put it down on paper, when I say paper, it's whatever, computer screens or your applications. Then you can visually see the problems happening, right? So when you break it down like that, I think it's easier to really look at the improvement opportunities.
Okay. You're an extremely accomplished individual, whether it comes to your work or your passions. How do you manage to have a proper work-life balance?
It's a good example. I still haven't found an answer. Everybody tells me that, but I don't take it in a very flattering way. I think if you just have to, again, you have to be lean yourself, right? You have to optimize your time that you have without wasting it. I don't think, my name is Prashant, okay? Shanta, right? You know what Shanta means. But I think all my friends, including my wife and kids, think I'm Ashanta, okay? So I'm just giving you an example because I'm not Ashanta in a very panic way, but I just never sit still. I'm always using my time. There are 6 different things waiting for me in my garage. And I know Yogesh also is a good builder. He works on projects. And I have a tree cut. I want to make a table out of it. I am making a drawer system right now to put it in the back of my car so I can go camping and have some storage for kitchen items or camping items. I have a rust proofing to be done to a certain thing. I have to do an oil change. So all these things are waiting. So whenever I have a time slot, I go do that, right? Then I prioritize my personal things. But again, your work is primary. So it all comes down to not wasting time, prioritizing what you have on hand, putting the importance to obviously work first because that is what is paying for you to have all this. Giving enough time for family, making sure their needs are what your passions are. When can I go do this hike? When can I go work on this project? When can I go get a motorcycle ride out during the weekend or in the evening? No, so I think it just comes by practice. If you just keep an open mind, if you keep the positive attitude, I think that's what has helped me.
And also, Prashant, I would add, work from home has helped a little bit more to balance
Absolutely.
out. Because whenever I am tired of, when am I running out of juice, then I just take Max for a walk.
Yep.
Like for 15 minutes, I do some projects in the basement. Mm-hmm. So that has helped too.
Yep, that's absolutely right. Yep.
Applying lean principles in daily life is a great way to look at it. Now we have a few more questions which go beyond lean manufacturing. What is the main drawback of Ford Motors in India? Why did it fall drastically?
Wow, that's a loaded question.
Good question.
I will attempt to see that again. All the different things, these high-level decisions are made on a very high level. We did hear the unfortunate news in his mind, but it all comes down to what we just talked about, right? If for a company to run efficiently and to exist globally in different areas, the bottom line is it has to be profitable. Okay, whether it's the operations are not running ideally, whether it's the company is not selling enough cars or not making enough profit. It may be selling cars, but at a loss, right? Or not making enough profit to sustain the operations that are in the country. Maybe there is the market is not there. Maybe those products are not in demand in that region. It may sell somewhere else like hotcakes, but it may not sell in another region. So so a lot of this, it's not one single answer, right? It's a multitude of factors that are weighed, and the decision is made based on that. And it is, trust me, it is not a very knee-jerk reaction, which is not a very, one day somebody wakes up and says, you know what, we are going to stop the production in India. No, it has been going on for a long time. We've done a lot of good things. We are not going to disappear from India. We are still going to have dealerships there, and you can still order some cars from the US. But what they're doing is they're just optimizing their operations. And every company has, these are very tough decisions, okay? I think Ford really loves India. They really love the culture of India. They really love the mindset and the hardworking grit that Indian people have. So because I've heard it firsthand from my leaders, right? So it's not that. It's about the company at the end of the day, after having a couple of years, I think, I don't know how many quarters, because all these finances are looked at on a very regular basis by the leadership, and then they take decisions based on that. So it's not a very, you cannot be emotional about that. Things have happened where people have laid off people, they have fired people, they have closed out departments, they've closed out factories, they've closed out lines. Now, you might have heard that Ford decided a few years ago to go away from small cars, right? So the only car we have is the Mustang, okay? And then we have all SUVs, because people, that's the demand, that's where the demand is. So some people might have said, you know what, Fusion was selling so great, Focus was awesome. Why did we close that? So those are, again, tough decisions. It's not one correct answer for that. So to come back to our India question, I think it was just, they gave it the full effort, but the operations there were not profitable. Otherwise, there was no reason to close that. Sorry for the long answer. Yeah.
Worked at Ford Motors for so many years. What factors should be considered before joining a particular company?
Great question. I think, look, I mean, I've worked for small companies. I've not always worked at Ford. Ford is a huge company, right? But I started off working in a very small company. I actually, from VJTI, I got placed in Deepak Fertilizers and Petrochemicals in Taloja. That was my first job. So I started as a maintenance engineer. But that time we did some research, make sure the company is doing good. It has good culture. It treats its people right. And they offer something that you want, which basically getting the experience, becoming a better engineer, becoming a better person, right? So it's a two-way traffic. It's not only, the companies are not doing a favor on you. Neither are you doing a favor on them, right? It's a two-way thing. They are getting the talent and the skill that they need with the right person of the right attitude, and you are getting the company to work where you'll be happy, you are challenged. Okay, remember, no job is simple. If you're not challenged at your job, that means you are a very easy job. Some people like doing that, but they never grow then. If you don't take up challenges, if you don't take up problems, face first, you're never going to grow, because you'll always be happy with current state and you'll always be happy with not having any problems, okay? So those are some of the things you want to look in a company. Do your own research, talk to them. When you go for an interview, guys, let's make it that conversation. I'm not saying being rude or cocky. It's being humble, but inquisitive, of understanding where I'm going to be working, and ask a lot of questions. Be knowledgeable, do your home interview. And that's all I say. I think, like I was saying, I started off very small, but that was by circumstance. I needed a job and I wanted to get started somewhere, but I was open for opportunities. I went for a small, after Deepak, I took up a job in L&T in Powai. And then I came here after a year and a half. I got my admits and all that. But here, when I started my first job after master's, I started a very small firm of 25 people, design firm. I was actually working on AutoCAD and working on the old drafting table type situation. And then I moved to another design and release position. Then I moved to another position before getting into Ford. So keep your options open, keep an open mind, always work hard, always keep the right attitude, and you will move forward.
Thank you for sharing your experience. Next question. Could you elaborate more on your titles of Six Sigma, Master Black Belt, and Kaizen Sensei?
Yes, good question. So those are some of the. It's like, you know, when you learn swimming, you're called, okay, he's a swimmer. Doesn't mean he does swimming all the time, but he can use it when it's needed, right? So those are some of the skills that I've gained. I was part of the quality organization for a long time. So while in manufacturing, I started my Six Sigma journey. Okay, I'm going to quickly spend some time on this. Sometimes they start at yellow belts, but green belt is where the Ford Motor Company starts. So green belt is when you're just starting to get into Six Sigma. Then black belt is when you actually can run your own projects. So you can go to a facility, identify the problems, measure the data, and work on solving problems. Now the next step to that is Master Black Belt Level 1, which is you are an established black belt. There is a next level certification you have to do, which is Master Black Belt certification. You have to go through a interview process. Sometimes there is a big American Society of Quality, ASQ. Sometimes you can also get their certification to support what you're doing. But Master Black Belt is really where you can look at mega projects, not just small projects, where you can look at not just fixing a tire and wheel vibration, but looking at the entire chassis department and where the performance group, right? So that's when you get promoted in that Six Sigma ladder as Master Black Belt Level 1. Now, what is Level 2? The Level 2 is, as Ford prescribes it, it's basically you've done the Master Black Belt Level 1 for a long time. You've managed a performance cell. You are good in your skills. And now you can actually share that and teach others to become Six Sigma practitioners, right? It may be, so black belts teach green belt classes, and Master Black Belt Level 2 teach black belts. So they actually I've conducted many classes to convert engineers into certified black belts. And I've also, when you are Level 2, you can also teach Master Black Belts around the world. So I've taught several different waves of people coming from Europe, coming from India, coming from Middle East to North America to go through the Master Black Belt classes. So that's the difference between green belt, black belt, and Master Black Belt. And one more thing, the Kaizen Sensei. So Kaizen is a methodology where it's a Japanese name, and Sensei is just a guru or teacher, right? So a Kaizen Sensei is a certified practitioner who is supposedly an experienced or an expert in that. So Kaizen is a methodology within Six Sigma. It's kind of related to Lean and Six Sigma, where you problem solve very quickly, okay? So imagine a Six Sigma project would go for a few months, okay? Kaizen Sensei would be done in a week. That is a very fast, quick, expeditious way of problem solving. So that's the Kaizen methodology, and Sensei is just the teacher or the coach or the expert, whatever you want to call it.
Those are impressive titles. Can you explain that what kind of skills must be developed to ensure a good career in technical as well as management fields?
I think that's a good question. It is very obvious. I think you guys are very smart individuals. You understand where you're going, right? So sometimes you don't exactly know where you want to go, but you kind of have a rough idea. Okay, you know what? I want to go in the mining industry, or I want to go in automotive, or whatever, right? Maybe I want to do an MBA in finance and go into finance operations of a manufacturing company, or I want to do IT or whatever. So mechanical is a great base to go wherever you want. Now, understanding what skills you need to develop is a basis of, okay, what do I know? What is my current skill set? Where do I want to go? and how do I empower myself to really train myself. Maybe it's a DIY training, or you go and do some certifications to get those skills. So those are things you can do on your own. You can do obviously more homework and become an expert in your field. But if you want to do something above and beyond and something new, you can always go and seek that knowledge. Obviously, on-the-job training is very important. So keep your eyes and ears open. Give your 100% in whatever job you're doing. Don't go after titles. Go after the content. Okay. Titles will get you somewhere only for a certain time. But if you have the right content, if you have the right talent, that will make you a stronger individual, and you will automatically grow. You just have to keep your eyes and ears open, and you should keep your mind open for opportunities. Don't ever settle for I don't have time for that. Okay, you can always make time if it's important enough for you.
Prashant, I would want to add both things will only follow passion. If you have passion, everything will come to you.
Absolutely. That was some priceless advice. Our next question is, how does someone become certified in lean manufacturing, Six Sigma?
So there are organizations that are lean that are basically not only teaching lean and Six Sigma, but also just because I'm not kind of out of touch with what Mumbai offers. But from a bigger perspective, there is a worldwide lean organization. You can actually lean.org, you can look at that. There is also the American Society of Quality, ASQ. So you can actually go through the certification process. There's an exam, there's material, and they also Six Sigma and lean or lean Six Sigma are a very common term. And just because it goes hand in hand, right? Six Sigma is all about improving quality and reducing defects and error proofing and really cutting the waste out. And that's what lean is. So lean Six Sigma is again combining those two methodologies. So you can look up what's available in your area, but from what I can tell you, the American Society of Quality is a one good thing to start. And it doesn't matter where you are in the world. I think I can sure, like ASME, ASQ, you can definitely join and get those certifications done.
I'm sure your responses has given all the listeners complete clarity about the queries raised and delivering an incredibly insightful lecture.
Adya,
yeah.
I think we should give opportunity for anybody else to ask the question too.
Absolutely.
Is it like a mandatory thing that only you will and means like?
No, sir. Actually, this lecture was being streamed on YouTube, so they can't directly ask the questions here.
Oh,
so that's why I was reading it out for.
Hey, she's the moderator. She's a moderator. Yeah.
Yeah. I understand. Yeah. Okay, got it. Because we are limited to 25. Yes, got it. Hey, Prashant. Okay. Hey, you said that waste on your slide. The second slide, you said waste, and there was the answer 98%. So what exactly that means? 98%. Are you saying that the waste is 98%?
So look at it that way. Don't look at it, oh my God, I mean...
98 is a huge number.
So that sounds, that's a shocking number.
Yeah.
But that all comes down to how you define value-added process versus non-value-added process. So everything that happens as a support, so what it really means is there is opportunity everywhere in the process. Okay, that's the bottom line. I'll give you a simple example. Imagine an assembly line. People are we're talking about manufacturing automotive, so let's go with that example. People are putting parts on, and then they're making sub-assemblies, then putting it in the car, and the car goes out of the plant and gets shipped to the customer, right? What the customer cares about is the final assembly of the proper assembly of the vehicle, and I'm getting a perfectly fine product which has high quality, right? And looks great, all that stuff. So that is what customer pays for. Everything else becomes a support activity. All the stuff that happens, the material is coming in, you are putting assembly, sub-assembly, putting it in the tank, putting it into the vehicle, all the stuff that is happening before, all the suppliers creating these 1,000 parts, and having their own processes, own logistics to send the parts over to the assembly. Imagine how much happens, all that stuff. In a way, yes, the customer is paying for it because they're writing the check for the car. But what the customer really means, I want the end product. So it's really, if you look at the why of FX, if you look at a fishbone, why is the end product is a perfect, high quality, beautiful looking vehicle that the customer is looking for. Everything else that happens to make it, it's kind of non-value added in a very harsh value added.
It's like a 20-80 rule.
Correct.
Ah,
yes.
Interesting.
Yes.
Prashant, one more. You say that lead time. On lead time, you said that everyone is trying to squeeze the lead time. Personally, I don't agree on that about the timing given for a particular production to start. So lead time is always precise. You only effectively use all the tools to make sure that you produce an optimized and best quality product at the end of, not end, but start of production. But yes, that's what I was misunderstanding. Why are everybody trying to squeeze the lead time?
So when you are saying it is perfectly happening and this is the lead time, that is the optimum, that is the target you should have, or what is your optimum lead time, right? And the reality is that, honestly, Ford is a pretty lean organization. I mean, it's becoming leaner and leaner. I don't want to see lean, it's very lean because it's, again, continuous improvement.
You will see skeletons. You don't want to see skeletons.
Well, I need to become lean, so I need to cut some fat. I know that, but that's a different topic for another day. But coming back to your question, the lead time, there's always opportunity. There's always things that are happening that are adding to the lead time, that is delaying the product. It could be, suppliers sending the parts to the plant, or the plant sending the lead time for when the dealership. You know what? When I go to the dealer, I want to order this, Mustang in green with a convertible top and black tires. I want the car tomorrow. Okay, it's like buying milk from grocery store. I want it today, right? That is my ideal thing. I want to, in fact, buy it right now from the parking lot. But it's not happening. So there is a lead time for my order to go back there. So that's the whole thing about how do I reduce that lead time from when the customer wants a product to when we can deliver it, when Ford Motor Company can deliver it.
Got it. Hey, Prashant, thanks. I finished my 5 minutes. I have finished my questions. Hey, great to listen from you, Prashant. It has really helped me. Actually, you know what? The problem was already detected and we have a solution for that. My wife just sent me an app saying that it's a cozy family we can download that can reduce some waste in our house. So,
awesome.
Great.
Share that with me. I'll use it too.
Absolutely.
Always looking for opportunities, right?
Yeah. So your lecture helped me, buddy.
Thank you. I appreciate the opportunity for sure. It was fun sharing this knowledge, and also it's a special thing because you guys are a VJTI. Okay, so thank you, Adya. Thank you, Yogesh. Yeah, thank you.
Thank you, Prashant ji, for your wonderful session. I'm making it again interesting by Yogesh. There's a great interaction that there's some few questions that may not be, the students cannot get it at this level. I think that Yogesh has made that certain new questions he added with the simple examples from his bounds. And that's really make this interesting. So I think that without wasting our time, I say, Adya, please, you can continue and give the vote of thanks. Already it's around, I think so, in India, 8:45 p.m. So, and no doubt we will meet again, Prashant ji, on some another platform also. And
I would love to.
get
Thank
some
you.
support from you for the VJTI, the young dynamic students, those who are pursuing their BTech and MTech.
You know what? I love to help that. I had a job within for that. Also, I was encouraging how do we reach to the younger folks, not only college but also high school and middle school. I have a passion in this, partly because not only I think I got it from my mom, who was a teacher all her life. So I think I love doing this, and when Yogesh approached me, it was like a no-brainer for me. I just immediately said yes.
That's why I approached you.
Adya, please you continue your
Thank you, sir.
Thank you. Thank you.
Yes, sir. Thank you, Jawkar sir, again for such a helpful lecture. And thank you, Tambat sir, for interacting with us again. Thank you both of you for taking time out of your busy schedule. I would like to end today's session with this quote by Henry Ford. Anyone who stops learning is old, whether at 20 or 80. Anyone who keeps learning stays young. The greatest thing in life is to keep your mind young. I hope you all keep learning and stay connected with ASME VJTI for more informative sessions and events. Thank you for joining us today. I wish you all a good night and a great day.
Thank you, Adya. Great quote. Have a good night, guys.
Prashantji, what we decided now that we will try to catch this all VJTI alumni maximum possible for us, and they will be spent suppose 1 hour with this our young dynamic people. I think that that will be help great to this new generation. They will be learn something new from these people, and hope so they will be get inspired from